Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSE at YourPedia. So today we'll be doing a question from our NPTEL question bank series, and we have selected question number 42 from computer architecture. You can find this question on page number 21 in the booklet. So the question is, you have been given a 5-stage pipeline. To the 5-stage pipeline with instruction fetch, instruction decode, operand fetch, execution and write operand cycles. So it is a 5-stage pipeline. Now instruction fetch, instruction decode, operand fetch and write back takes 7 clock cycles for all the instructions, and the execution state, the 4th state, takes 9 cycles for add and subtract and 21 cycles for multiplication operation. 9 cycles for all add and subtract instructions and 21 cycles for multiply operation. Now operand forwarding is used. Operand forwarding is used for data dependency, and when the opponent fetch instruction will be completed, only after that you can fetch the instruction using fetch the operand using operand forward technique. What will be the number of clock cycle needed to execute the following sequence? You have been given 3 instructions: addition, subtraction and multiplication. So you have been given number of clock cycles, you have been given instructions, you have been given the stages of pipeline, and you have to find the total number of clock cycles if you execute these 3 instructions. So first of all, let us assume that we don't have any pipeline and we take these 3 instructions. Now for these 3 instructions, these are the 5 stages. Now information fetch will take 7 cycles, information decode will take 7 cycles, operand fetch will take 7 cycles, and execution will take 9 and then again 7. For subtract again 7, 7, 7, 9 and 7. So this will be 37 for this and 37 for this. For this you have to take 7, 7, 7, 21, 7. It will be 49. So the total number of cycles required if you don't use pipeline is 123 cycles. So what is the use of pipeline is to we use pipeline in order to execute our instructions in a more compact way, so that we can save the number of clock cycles. So that's why we use pipeline. So let's say we use pipeline and without operand forwarding technique and without any knowledge that we have just 3 instructions: add, subtract and multiplication. So let's do this. Now first instruction is addition instruction. We will mark these as 1, 2 and 3. Now the first instruction is addition. Now for addition you need 7 cycles of information fetch. So it will be executed like this: 7 cycles for this, then 15 to 21, 7 cycles of this, then you will take 9 cycles of EX, 22 to 28, 29 and 30. After that 31 to 37 and it will be executed. Now in normal cases what we will do is first add will be completed, then after that we will move towards the subtract instruction. But in this pipeline, when information fetch, we divide all the instructions into 5 parts, 5 stages of pipeline. When information fetch is completed for instruction number 1, it will go on to information decode, and when it is on information decode, the information fetch pipeline stage will be free. So the next instruction can use that information fetch cycle, information fetch stage for in the meantime, so that we can save number of clock cycle. In the clock cycle, when first instruction which will be information decoding, in the meantime we will be performing information fetch for the second instruction. So let's say second instruction will take 7 cycles for information fetch. Now after that it will move on to information decode, and when operand fetch of this will be completed, it will move on to the information operand fetch. Now when operand fetch is completed, you can see that the first instruction has not completed its execution part. So it will wait in the pipeline for the execution stage to be free. So when execution of the first instruction is completed, it will move to the write back operation. Now when the first instruction moves to the write back operation, execution stage pipeline will be free. Now you can execute the second instruction here. Now second instruction needs how many? 9 cycles to perform the operation. Now when the execution part is completed for the second instruction, it will move to the write back, and it will perform it write back till 46 because it needs 7 cycles for it. Now when the information fetch cycle of second operation is completed, second instruction is completed, we will perform information fetch for the third cycle. Now when the information decode for second is completed, we will move third here. Now until it completes operand fetch, the second instructions complete operand fetch, 3 will wait in the queue for its turn, and when the second instruction will move to the execution state, our third instruction will be placed here. Now it will perform its operand fetch here, and it will wait for execution state to complete its instruction. So it will wait here. Now when the execution stage is free, 3 will be moved to the execution state, and it will take how many cycles? 21 cycles. So it will take 21 cycles because it is a multiply instruction, and multiply instruction take 21 cycles on the execution stage. After that it will complete its 7 instructions, 7 cycles on the write back. So the total number of cycles required are 67. But there is a catch in this question. What it is? In this question, we have data dependency. Like the result of addition will be stored in R1, and that R1 will be used as a operand by subtract instruction, or you can say second instruction, and the result of the second instruction will be used by multiply instruction as an operand. So there is a data dependency. You cannot perform the operation directly because then it will change the result. Suppose that R1 value is 5 initially. Now if you take R1 as value as 5, and let's say R5 is 4, R6 is 6. Now when you add these two, R1 value will be 10, and this 10 value will be of R1 will be used in the subtract option. Let's say R7 is 14. So the correct option for subtract should be R10 should be equal to R7 minus R1, which is equal to 14 minus 10, which is equal to 4. But the way we use the pipeline, what we are doing is, four, 6, 5 and 14. So what we are doing here is, in information fetch we will fetch the instruction, in information decode we will decode the instruction, and when we will fetch the operands for first instruction. Now the execution takes place in these cycles. Now after completion of these cycles, value of R1 will be updated here. After write back, R1 will be updated to 10. Till then the value of R1 will be what? 4, or what we have taken is 5, I guess. Value of R1 is 5. But you can see the second instruction is fetching the operands here. So when it fetches the operands here, it will fetch R7 as it is, which is 14, but it will fetch R1 as 5 because the R1 has not been updated yet. So the R1 which will be fetched will be 5. So 14 minus 5 will be 9, and after execution answer will be 9, but it should be 14 minus 10 equal to 4. So because we are fetching the R1 value before it has been updated by the add instruction, this will give wrong answer. This is called data dependency. So for this we have to wait some time in order to fetch the R1 instruction. Now it will obviously increase the number of cycles as you have to wait indefinite amount of time, but we will use operand fetch technique. It is saying that we can use operand forwarding, we will use operand forwarding technique to in order to decrease the number of cycles in our instruction execution. So let's see how this will go. First of all, information fetch 7 cycles for the first instruction, 7 cycles for the second, 7 for the third, and 9 instructions for the fourth instruction, and then here it will be write back. Now it is saying that by using operand forwarding technique, operand fetch stage of the dependent instruction will be executed only after the previous instruction completes EX. Now if you want to fetch the operand, you can fetch the operand after the previous instruction has completed its execution state. So you don't need to wait till this, when the write back is over. You can fetch the instruction when execution cycle of the state is done. So you will perform the second instruction here, second instruction here. Now you will not start the operand fetching till the execution phase of the previous instruction has been done. So when the execution is done, R1 will be 10 for this. You will fetch that R1 from here. You will fetch that R1 from here and then continue the operand forwarding. Now after fetching the R1 from the first instruction, now you have R1 and you have R10 and you can perform the subtract of operation, but you have to fetch more operands because you have fetched only R1 from the previous instruction. So in order to perform those fetch operations, you have to give 7 clock cycles again. So 7 clock cycles here. After that you can perform the execution state, which will take how many? 9 instruction cycles, and then after that write back for this, which will take 7 instruction cycles. Now when the third operation is done, it is multiply. Now in multiply again there is a dependency. You need the R10 that has been subtracted using the subtract instruction, second instruction. That R10 will be used as an operand in the multiply operation. So in order to do that, again we will use operand forwarding technique. Now information fetch will be done normally, information decode will be done normally, and it will wait for its turn to operand fetch. Now it cannot start the operand fetch till the execution part of the second instruction is done. So it will again wait here. Now when the execution part of the instruction is done, subtract instruction is done, you will get R10 directly from here. Instead of waiting for R10 till the write back stage of the pipeline is completed, we will directly fetch the operand from here using operand forwarding technique, but you have to fetch other operands also. So for that, how many cycles we will require? We will require 7 cycles. So here you will fetch by using these 7 cycles, you will fetch all the remaining operands. Now after this, it has been given that for execution state 21 cycles are required for the multiplication operation. Other operations were taking 7 clock cycles each, but for multiply it will take 21 cycles for the execution stage. So if it takes 21 cycles, so one cycle here 54 to 74, it will take 21 cycles here, and after completing the execution state it will move to the write back stage and take 7 cycles there. So total number of cycles required are 81. Now as you can see in this question, if you don't use the pipeline, the number of cycles required were 123. So we use pipeline to reduce the number of cycles, to save the number of cycles. So we used pipeline here. So the number of cycles were reduced to 67. But as there are data dependencies, also known as hazards, so if hazards are present in our instructions, then the number of clock cycles will increase, because hazards are directly related to the number of stalls. So if number of stalls are increasing, this means the number of clock cycles will increase, because if you don't consider these hazards, then the answer will not be correct because of the dependencies present. In this case, data dependency was present in our instruction. So in order to solve that data dependency, we used operand forwarding technique. What we do in operand forwarding techniques, instead of waiting till the write back stage, we will get the result directly after the execution. Whenever the execution is completed, that R1 has been updated by the add instruction, it will give back the result to the subtract instruction so that it can perform its operand fetching cycle. So without the pipeline, the number of cycles were 123. If in the second case we use the pipeline, but we ignored the data dependencies in. So if we ignored the data dependencies and use the pipeline, the number of cycles were 67. But the answer would have been wrong, because the number of stalls would have been surely more than this, and the answer would have been wrong if we use pipeline by ignoring the number of data dependencies present in our question. So if we take into consideration the number of data dependencies present, and to solve those data dependencies we used operand forwarding technique, the number of cycles were reduced to 81. Though it is more than the previous case, but in previous case the answer would have been wrong. So the correct answer is 81. By handling the data dependencies, the hazard, the stalls that has been caused by those data dependencies, the number of cycles required are 81. So I hope you understood the question, and keep watching for more interesting videos like this. So thank you and keep watching.